Euclid's 44th proposition says that given a triangle, an angle, and a line segment, we should be able to construct a parallelogram whose one of the sides is the given line segment, one of the angles is equal to this angle, and the area of the parallelogram is equal to the area of this triangle. Now this is going to be hectic. So let's tighten our belts and take it step by step. As part of our previous propositions, we have seen how to create a parallelogram whose area is equal to this triangle. We have to make sure that that parallelogram and this triangle is between the same parallel lines, and that parallelogram starts from the midpoint of BC. Okay, so let's start off. So let's first convert this BC line segment into a line, right? Now we have to find the midpoint of BC. How do we do that? We draw a circle with B as the center and BC as the radius. Similarly, we draw a circle of with center as C and BC as the radius. Now these two circles intersect each other. So we mark the points of intersection I and J. Now let's connect these intersection points. Now this line segment in turn intersects the line BC. So let's mark the point of intersection. Let's say K. Now we don't require all these circles and all that, because our objective at this point of time was to find the midpoint. So let's hide all the remaining things. Okay, so we have got the midpoint. Now at K and C, we have to copy this angle. Again, we know how to copy the angles. Draw a circle with center at K and DF as the radius. Then we draw a circle with K as the center and DE as the radius. Outer circle, that is of radius DE, intersects this line. So let's mark the point of intersection of that circle with this line. Now it intersects at 2 points. We are only interested in this. So let's mark that as L. Now with center as L, let's draw a circle of radius FE. FE. Now this is the DE, this circle. This circle is FE. So intersect. So let's say M. So now let's draw a line KM. Now this angle CKM is equal to this angle. Want to confirm it? Just move this around. You will see as this moves, that also moves. Okay. Now we don't require all this. Same thing we have to do at C. We have to copy this angle at C. So what do? We draw a circle with center at C and DF as the radius. Basically, we are repeating it for point C. Circle with C as the radius and DE as the radius, and the intersection of this line and this circle. So that is, and we want only one of them. So let's say N. Now again we draw a circle with N as the center and FE as the radius. Again we are interested in the intersection point of this circle and the smaller circle, and only one of them. Okay, let's say O. Now we join these and form a line. So line OC. Now we don't require all these. So let's hide all of this. So this angle is equal to this angle is equal to this angle. We have to make sure that the parallelogram and this triangle is between the same parallel line. So we have to draw a parallel line through A, parallel to this line. How do we do that? If we treat this line and the proposed line, AB will be a traversal through those two lines. We just make sure that the alternate angles between those two lines is equal to ensure that they are parallel. So how do we do that? So let's draw a circle with center at A and BC as the radius, and again a circle with B as the center and AC as the radius. Now these two circles intersect each other. We are interested only in one of them, this one. Now let's join this point P with A and form a line. So we have a parallel line. Again, we don't require all this. First, let's take care of this. CBA. Similarly, angle PAB. Okay. So these two angles are equal. This angle is equal to this angle and this angle is equal to this angle. They are corresponding angles and they are equal. So that means these two lines are parallel. Okay. Now we have points of intersection here and here. So let's mark those points of intersection. Yes, Q, and again intersection point of R. Now we don't really require those two lines. We have got what we needed. Now let's join these points AQ, RC. Okay, now this parallelogram is equal to this triangle, the area. Now we have to construct a parallelogram whose area is equal to this along this line. Okay, till now we have used the previous proposition itself. Extend this line GH to form a line with center as H. We draw a circle of radius CR. Now we copy this angle, or rather this angle at H. We know how to do that. Circle with center at H and DE as the radius. Similarly, H as the center and DF as the radius. Let's make a circle with center. Okay, we need the centers. So let's look at the intersection of these two, the inner circle with the line. So we have got this intersection point. Now keeping T as the center, we draw a circle of radius FE. Again we get an intersection between these two circles. We need only one of these. If we join these two and form a line, this angle would be equal to this angle. Again, if you want to confirm it, you see, as you move this angle also changes. So let's form the line by connecting H and U. Now, we don't require these circles now. We need only this. Now, keeping S as the center and KC as the radius, we draw a circle. Okay. Now, keeping H as the center and KR as the radius, we draw a circle. Now, these two circles intersect at this point. So let's join those. So first let's mark that intersection of these two circles, and we need only one of the intersections. So again we don't need these circles. So let's form a line between these two line segment. Again from H we draw a circle with center as H and KC as the radius. Again we get an intersection and we need only one of them. Now keeping these two, we draw a line VW. Now this line is parallel to this line. Let's first of all hide off this circle. Now keeping G as the center and KC as the radius, we draw a circle. Now this circle and this line intersect each other. Now we join ZG and we hide this circle. Now let's hide this line and let's join them using line segments. And we don't require this line as well. And let's join WH. Okay. Now what we have to do is make a parallelogram here equal to this parallelogram. Because remember, our requirement is what? One of the sides of the required parallelogram should be HG. So this parallelogram is equal to this parallelogram. But this is not one of the sides. So we have to construct a parallelogram here. But for that we know that complementary parallelograms are equal to each other. So we have to create a complementary parallelogram here. So let's do that. Let's extend VS. Let's extend WH. Let's extend ZG. Remember, we need a parallelogram equal to this because this is equal to this. We will see how it is equal to it at the end. So which means the complementary parallelogram to this would be here. That means our diagonal has to be here. So we draw a line from Z to H and beyond. And now we look at the intersection of this line and the line VS. So we have got the intersection point. So this is the diagonal for the coming up parallelogram. So now we don't need this line. And now we can draw a parallel line parallel to SG. How? Just draw a circle at H of radius SA1. Now this is our intersection point of this circle with the line. So intersect this circle with this line. Similarly, we need the intersection point here as well. So again we draw a circle with G as the center and SA1 or HB1 as the radius. And again we take the intersection point of the circle and this line. Okay. Now we don't need these circles, so let's hide off these circles. And now let's join all these points. So line segment A1, B1, segment B1, C1. And now we don't need these lines. And now let's join these. So now what are we claiming? What are we saying? We are saying that this parallelogram HGC1B1 is the required parallelogram which has one of its sides as HG, one of the angles equal to this angle, and the area of this parallelogram is equal to this triangle. So let's see how we can prove this. This part is, I think it is clear through one of our previous propositions. We know that the area of this parallelogram is equal to this triangle because it is starting from the midpoint of this triangle. Okay, and they are between the same two parallel lines. Okay, now how can we say that this parallelogram is equal to this parallelogram? Because remember, this angle CKQ, this triangle is equal to this triangle. This triangle is equal to this triangle, angle SHW, right? Because that is how we copied it. This is equal to this, right? and HS is equal to CR, and they are between same parallel lines. So this side is equal to this side is equal to this side. So they are equal parallelograms. Now this angle GHB1 is equal to SHW. Why? Because they are vertically opposite angles. And we know that this area is equal to this area. Why? Because one of our previous propositions we have proved that complementary parallelograms are equal to each other. So this is equal to this is equal to this is equal to this. That means this is equal to this. Again, if you want a bit more detailed explanation where you can take your own time, please refer to the PDF book which I have provided a link in the description, which describes all the 48 propositions of book 1 of elements. So this was proposition 44. And the fun part is this: if I change this triangle, you see the triangle changes, that means this parallelogram changes, that means this parallelogram changes, that means this parallelogram changes. And it will always be equal. A, you can move A, you can move C. Accordingly, this changes. We can also change the angle. And we can change the length of the given line segment as well. As I increase the length, the width decreases. As I reduce the length, width increases. Just to make sure that this area remains equal to this, which in turn remains equal to this, which in turn remains equal to this. That is it. Bye.